master lulusan Amerika, Belanda, Jerman, Inggris, Taiwan, Malaysia, Thailand, dan tentu saja Indonesia. Bahkan ada di antara mereka yang sudah bergelar profesor atau sedang menunggu persetujuan untuk gelar guru besar mereka.
Kami sangat optimis dengan prospek jurusan Statistika UN
Amerika. Kenyataan bahwa para alumni statistika ini relatif mudah mendapatkan pekerjaan sama sekali tidak mengejutkan. Karena selain fasilitas dan sumber daya manusia yang mendidik mereka, para mahasiswa statistika juga termasuk yang sangat aktif berorganisasi dan berprestasi, baik prestasi akademik, penalaran, maupun di bidang seni dan olahraga. Lagi-lagi fakta ini juga tidak mengejutkan, karena persaingan untuk menjadi salah satu mahasiswa statistika USK tidaklah mudah. Karena program studi ini merupakan salah satu program studi yang sangat diminati oleh para calon mahasiswa. Sepertinya, para calon mahasiswa ini juga sudah sangat mengerti bahwa tiada hari tanpa data-data. Dan agar data-data ini berubah menjadi energi, solusi, atau rekomendasi, maka yang dibutuhkan adalah statistika.
Tak perlu berpikir dua kali untuk menabung. Ku aman, ada LPS. Semua cita-citaku pasti akan tercapai. Ku aman, ada LPS. Sekarang menabung tak perlu khawatir lagi. Ku aman, ada LPS. Ada lembaga penjamin simpanan untukku. Ku aman, ada LPS. Gapai cita mulai dari menabung. Ku aman, ada LPS. Kepastian untuk melangkah maju. Ku aman, ada LPS. Gapai cita mulai dari menabung. Ku aman, ada LPS. Kepastian untuk melangkah maju. Ku aman, ada LPS.
Salam teka di Bumo Seramo Mekah, negeri memesona dengan semangat pembangunan menggelora. Provinsi Aceh merupakan provinsi paling barat Indonesia.
Seiring dunia yang semakin terbuka dan perkembangan era yang sangat dinamis, setiap individu dituntut untuk memahami dengan cepat dan tepat fenomena dan data-data yang tersaji secara tiba-tiba. Sementara itu, perkembangan pesat teknologi informasi dan komunikasi telah menyajikan miliaran data-data baru yang tidak mudah untuk dianalisis dan dipahami. Fakta ini memberitahu kita bahwa era big data saat ini sedang sangat Seiring dunia yang semakin terbuka dan perkembangan era yang sangat dinamis, setiap individu dituntut untuk memahami dengan cepat dan tepat fenomena dan data-data yang tersaji secara tiba-tiba. Sementara itu, perkembangan pesat teknologi informasi dan komunikasi telah menyajikan miliaran data-data baru yang tidak mudah untuk dianalisis dan dipahami. Fakta ini memberitahu kita bahwa era big data saat ini sedang sangat membutuhkan sumber daya manusia yang mahir dalam bidang statistika. Kebutuhan ini bahkan semakin tinggi di masa depan, seiring aktivitas manusia yang semakin berkembang. Fakta inilah salah satunya yang mendasari lahirnya program studi statistika Fakultas MIPA Universitas Syah Kuala pada tahun 2012. Program studi ini lahir sebagai program studi statistika pertama di Pulau Sumatera. Visi program studi statistika sangat realistis namun bertenaga, yaitu menjadi pusat keunggulan pendidikan dan penelitian statistika dan aplikasinya di Pulau Sumatera yang berakreditasi tinggi secara nasional dan dikenal secara internasional pada tahun 2025. Perjalanan program studi statistika menuju pencapaian visinya ini terlihat berada di trek yang benar. Selain itu, program studi yang bernaung di bawah jurusan statistika ini juga sedang mempersiapkan program studi baru Magister Statistika dan Data Science. Visi mereka sama sekali tidak naif, mengingat fasilitas yang dimiliki jurusan statistika saat ini sudah sangat memadai. Apalagi sumber daya manusianya adalah para doktor atau master lulusan Amerika, Belanda, Jerman, Inggris, Taiwan, Malaysia, Thailand, dan tentu saja Indonesia. Bahkan ada di antara mereka yang sudah bergelar profesor atau sedang menunggu persetujuan untuk gelar guru besar mereka.
Kami sangat optimis dengan prospek jurusan statistika USK, apalagi kita sedang dihadapkan dengan era data dan kebutuhan akan data. Speak with data menjadi isu sentral yang diperhitungkan di lembaga manapun saat ini. Dan di masa depan, urgensi data ini akan semakin menguat. Dengan potensi yang jurusan statistika USK miliki, serta sumber daya yang kami punyai, insya Allah sepenuhnya kami yakin para alumni jurusan ini akan sangat dibutuhkan oleh semua lini.
Sebagian besar lulusan program studi ini bekerja sebagai data analis di berbagai institusi dan lembaga pemerintahan ataupun swasta. Menjadi data verifikator di kementerian, perbankan, Polri, atau di berbagai institusi lainnya. Ada juga yang malah menjadi perwira karir TNI, dan bahkan ada yang diterima untuk bekerja sebagai research scientist di New York, Amerika. Kenyataan bahwa para alumni statistika ini relatif mudah mendapatkan pekerjaan sama sekali tidak mengejutkan, karena selain fasilitas dan sumber daya manusia yang mendidik mereka, para mahasiswa statistika juga termasuk yang sangat aktif berorganisasi dan berprestasi, baik prestasi akademik, penalaran, maupun di bidang seni dan olahraga. Seiring dunia yang semakin terbuka dan perkembangan era yang sangat dinamis, setiap individu dituntut untuk memahami dengan cepat dan tepat fenomena dan data-data yang tersaji secara tiba-tiba. Sementara itu, perkembangan pesat teknologi informasi dan komunikasi telah menyajikan miliaran data-data baru yang tidak mudah untuk dianalisis dan dipahami. Fakta ini memberitahu kita bahwa era big data saat ini sedang sangat membutuhkan sumber daya manusia yang mahir dalam bidang statistika. Kebutuhan ini bahkan semakin tinggi di masa depan, seiring aktivitas manusia yang semakin berkembang. Fakta inilah salah satunya yang mendasari lahirnya program studi statistika Fakultas MIPA Universitas Syah Kuala pada tahun 2012. Program studi ini lahir sebagai program studi statistika pertama di Pulau Sumatera. Visi program studi statistika sangat realistis namun bertenaga, yaitu menjadi pusat keunggulan pendidikan dan penelitian statistika dan aplikasinya di Pulau Sumatera yang berakreditasi tinggi secara nasional dan dikenal secara internasional pada tahun 2025. Perjalanan program studi statistika menuju pencapaian visinya ini terlihat berada di trek yang benar. Selain itu, program studi yang bernaung di bawah jurusan statistika ini juga sedang mempersiapkan program studi baru Magister Statistika dan Data Science. Visi mereka sama sekali tidak naif, mengingat fasilitas yang dimiliki jurusan statistika saat ini sudah sangat memadai. Apalagi sumber daya manusianya adalah para doktor atau master lulusan Amerika, Belanda, Jerman, Inggris, Taiwan, Malaysia, Thailand, dan tentu saja Indonesia. Bahkan ada di antara mereka yang sudah bergelar profesor atau sedang menunggu persetujuan untuk gelar guru besar mereka. Seiring dunia yang semakin terbuka dan perkembangan era yang sangat dinamis, setiap individu dituntut untuk memahami dengan cepat dan tepat fenomena dan data-data yang tersaji secara tiba-tiba. Sementara itu, perkembangan pesat teknologi informasi dan komunikasi telah menyajikan miliaran data-data baru yang tidak mudah untuk dianalisis dan dipahami.
Symbolic Explore 2024.
Yaitu Statistic Explore tahun 2024.
Menyaksikan acara Statistik Explore
Sangat mengapresiasi hadirnya Statistic Explore.
Statistic Explore yang mungkin terbaik yang pernah saya lihat untuk level mahasiswa.
Dengan resmi kami tutup.
Hai semua, aku Biko, lebah cerdas yang melambangkan semangat kolaborasi dan kekuatan data dalam membangun ekonomi yang tangguh, cerdas, dan berkelanjutan. Aku merupakan maskot Statistic Explore 2025. Di kepalaku ada lambang sigma untuk menunjukkan jumlah total dari sekumpulan data, sehingga dalam konteks stabilitas ekonomi mampu memberikan ketelitian, akurasi, dan keandalan informasi dalam mendukung stabilitas keberlanjutan keuangan. Di tanganku ada koin bertuliskan rupiah, simbol mata uang Indonesia. Simbol ini merepresentasikan komitmen Biko dalam mendukung pertumbuhan ekonomi yang berkelanjutan dan seimbang. Aku juga membawa smart tablet dengan grafik naik yang merepresentasikan kemajuan digital dan tren pertumbuhan ekonomi. Dan sayapku, semangat untuk terus tumbuh, bergerak maju, dan mencapai stabilitas ekonomi yang berkelanjutan. Itulah aku, Biko. Selebah cerdas yang akan menemani kalian semua selama Statistik Explore 2025. Sampai jumpa di setiap keseruannya.
Assalamualaikum warahmatullahi wabarakatuh. Yang terhormat, Dekan Fakultas Matematika dan Ilmu Pengetahuan Alam Universitas Syahkuala, Bapak Profesor Dr. Taufik Fuadi Abidin, SSIMTech. Yang kami hormati, President-elect of International Statistical Institute, Bapak Profesor Fabrizio Ruggeri. Yang kami hormati, Kepala Badan Pusat Statistik Kepala Badan Pusat Statistik Kota Banda Aceh, Bapak Teddy Herdiawan, SOS MAP. Yang kami hormati, Direktur Eksekutif Surveillance, Data, dan Pemeriksaan Asuransi, Bapak Dr. Suwandi AK MMCA.
Yang kami hormati, Kepala UPTD Statistik Diskominsa Provinsi Aceh, Bapak Said Ashari ST MSI. Yang kami hormati, Ketua Forum Pendidikan Tinggi Statistika, Bapak Dr. Bagus Sartono SSI MSI. Yang kami hormati, Ketua Departemen Statistika Universitas Syah Kuala, Ibu Profesor Dr. Zunila Marlikesuma, SSMSI, serta seluruh tamu undangan yang kami cintai. First of all, let's thank Allah, the Lord of the world, the King of the Day of Judgment, who has given us a plenty opportunity to attend and participate in the opening ceremony of Statistics Explore 2025.
Puji dan syukur kehadirat Allah Subhanahu wa Ta'ala yang telah memberikan kita kesehatan dan kesempatan sehingga kita dapat berhadir di acara Opening Ceremony Statistic Explore 2025.
Peace, love, and salutations to our Prophet Muhammad Sallallahu Alaihi Wasallam, who brings us into the right way of life and leave all the darkness.
Salawat dan salam kepada Nabi Muhammad Sallallahu Alaihi Wasallam yang telah membimbing kita dari alam kegelapan ke alam yang terang benderang seperti yang kita rasakan pada saat ini.
Ladies and gentlemen, I am Aisyah Nur Allah and my partner Imam Adli as your masters of ceremony today.
Hadirin yang berbahagia, saya Imam Adli dan rekan saya Ratu Suci Nurul A'la yang akan memandu acara kita pada hari ini.
To bless our event today, let's listen to the recitation of Holy Quran by Irfan. To Irfan, time is yours.
Untuk memberkahi acara kita hari ini, marilah kita dengarkan lantunan ayat suci Al-Quran yang akan dibacakan oleh Saudara Irfan. Kepada saudara, kami persilahkan.
Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. في خلق السماوات والأرض واختلاف الليل والنهار لآيات لأولي الألباب. الذين يذكرون الله قياما وقعودا وعلى جنوبهم. وعلى جنوبهم ويتفكرون في خلق السماوات والأرض ربنا خلقت هذا باطلا سبحانك فقنا عذاب النار ربنا إنك من تدخل النار فقد أخزيته وما الظالمين من أنصار وما للظالمين من أنصار صدق الله العظيم. Assalamualaikum warahmatullahi wabarakatuh.
The next event, let's sing the national anthem Indonesia Raya.
Acara selanjutnya, marilah kita menyanyikan lagu kebangsaan Indonesia Raya.
Ladies and gentlemen, please stand up.
Hadirin dipersilahkan untuk berdiri.
Ladies and gentlemen, are welcome to sit back.
Hadirin dipersilahkan untuk duduk kembali.
The next event is the report by the chairman of the committee. To Heru Bagus Cahyo, time is yours.
Selanjutnya, laporan Ketua Panitia oleh Saudara Heru Bagus Cahyo. Kepada Saudara, kami persilahkan.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. The Honorable Professor Dr. Taufik Fuadi Abidin, SSI MTech, Dean of the Faculty of Mathematics and Natural Science. The Honorable Professor Fabrizio Ruggeri, President-elect of the International Statistical Institute. The Honorable Mr. Teddy Herdiawan, Head of Banda Aceh City Central Statistic Agency. The Honorable Dr. Bagus Sartono, Head of the Forum Pendidikan Tinggi Statistika. The Honorable Mr. Syed Azhari STMSI, Head of the UPTD Statistik Diskominsa of Aceh Province. The Honorable Professor Dr. Jurnila Marli Kusuma SSI MSI, Head of the Department of Statistik Universitas Syah Kuala. Distinguished lecturer, invited guests, and all participants who are present here today. Alhamdulillah, today the Student Association of Statistics Faculty of Mathematics and Natural Science Universitas Syah Kuala once again hold its annual event Statistic Explore, which has been running since 2018. I, Heru Bagus Cahyo, as the chair of the committee, warmly welcome as discussing guests, lecturer, and participant to Statistic Explore 2025. Statistic Explore 2025 carries the theme Economic Stability Through the Power of Big Data, Innovative Strategies for Building a Resilient and Sustainable Economy. This theme highlights our effort in leveraging big data and innovative strategy to create economic stability. Statistic Explore 2025, there are 6 main activities, namely the National Seminar, Student Forum, our software training, big data competition, data science competition, and videography competition. The total number of participants in this event is 1,089 participants, consisting the national seminar with 686 participants, the student forum with 45 audience and 14 participant teams, the art software training with 180 participants, the big data 50 teams, the data science competition with 33 teams, and the videography competition with 11 teams. We hope the Statistic Explorer will serve a platform for students, pupils, and the general public to actively contribute to shaping a better future. We would like to express our deepest gratitude to our sponsor, Lembaga Penjamin Simpanan, Aceh Province Central Statistik Agency, Bank Indonesia, Perumdam Tirta Daroy, dan PT Riza Utama Perkasa, as we all media partner who have support this event. Finally, my highest appreciation goes to the entire committee, their dedication and commitment to making this event a success. To conclude my report, I sincerely apologize for any shortcoming and thank you for kind attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for your willingness.
Terima kasih saudara atas kesediaannya.
Ladies and gentlemen, next, we would like to invite Head of Forum Pendidikan Tinggi Statistika to give a welcoming speech at the opening ceremony of Statistic Explore 2025. To Dr. Bagus Sartono, SSI MSI, time is yours.
Hadirin yang berbahagia, selanjutnya kata sambutan yang akan disampaikan oleh Ketua Forum Pendidikan Tinggi Statistika. Kepada Bapak Dr. Bagus Sartono, SSI MSI, kami persilahkan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrahmanirrahim. Allahumma sholli ala Muhammad wa ala ali Muhammad. The Honorable, the Dean of Faculty of Mathematics and Natural Sciences, Professor Taufik, the Honorable Professor Fabrizio Ruggeri, President-elect of International Statistical Institute. Welcome, Professor Fabrizio, to Indonesia. And the Honorable Professor Zurnila Marli Kusuma, the Head of Department of Statistics, Universitas Syekh Kuala, and the Honorable all guests, professors, lecturers, and of course, all students of Universitas Syekh Kuala. I am very happy to be here. Thank you very much to the Committee of Stat Explore for invite me or us. For Stat is the association of 70 universities in Indonesia which organize statistics study program, and we have high commitment to develop statistical science, data science in Indonesia by providing the excellent learning environment for students. And we expect, of course, in the future, the development of statistical science and data science in Indonesia will contribute a lot to the development of Indonesia in general. The existence of Stat Explore is one of the commitment of Universitas Syekh Kuala, especially the Department of Statistics, led by Professor Zurnila, to promote the utilization of statistics to improve the quality of development, especially in Aceh province. As the chairman of Forstat, we would like to thanks to Professor Junila and all the staff, all students in Universitas Syekh Kuala that consistently organize Stat Explore. I think every year Stat Explore invite many students to involve in seminar, in data science competition, statistical competition, and it is very good to help Universitas Syekh Kuala in general again to extend the benefit to the community. And again to Mas Bagus Cahyo, congratulations to the organizing this event. I hope if everyone will have, yes, thank you very much, and hopefully everyone will get benefit from this event. Thank you very much. Billahi taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for your willingness.
Terima kasih Bapak atas kesediaannya.
Now, we would like to invite our dean to give a speech as a mark at the opening ceremony of Statistics Explore 2025. To Professor Dr. Taufik Fadi, SSI MTech, we welcome you.
Selanjutnya, kata sambutan yang akan disampaikan oleh Dekan Fakultas Matematika dan Ilmu Pengetahuan Alam Universitas Syah Kuala. Kepada Bapak Profesor Dr. Taufik Fadi Abidin, SSI MTech, kami persilahkan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hamdan wa syukurillah, salatan wa salaman ala rasulillah. The Honorable Professor Fabrizio Ruggeri, hopefully I pronounced it right, the President-elect of the International Statistics Institute, welcome to Banda Aceh. The Honorable Executive Director of Surveillance, Data and Insurance Examination, Indonesia Deposit Insurance Corporation, or also known as LPS, Dr. Suwandi, AKMMCA, who's attending online. The Honorable Head of Statistics Indonesia, Banda Aceh, Bapak Teddy Herdiawan, the Honorable Chairperson of the Statistic Higher Education Forum, also known as Forstad, Dr. Bagus Sartono from IPB University Bogor, welcome to Banda Aceh. The Honorable Head of the Technical Implementation Unit for Statistics, Aceh Communication, Informatics and Statistics Agency, Bapak Said Azahari, Master of Science. The Honorable Head of the Department of Statistics, Faculty Mathematics and Natural Sciences, Universitas Syah Kuala, Professor Dr. Zunila Marli Kesuma. Chairman of the Statistics Explore Committee, Mas Bagus Cahyo. You did a great speech and report. Statistic Class 2022. Big applause for Statistic Class 2022. Distinguished guests, colleagues, lecturers, students, and all the committee members. It is an honor for me as the Dean of the Faculty of Mathematics and Natural Sciences, Universitas Syah Kuala, to stand before you today to welcome the 8th Statistics Explore 2025, the annual program organized by the Statistics Student Association from the Department of Statistics. This year, Statistics Explore 2025, as mentioned and reported by Mas Heru Bagus Cahyo, has 6 academic activities, competitions, forum, and also a training. Each of these activities has been carefully designed and sharpen analytical thinking, foster innovation, and strengthen the capacity of the student and the participant to face the challenge of the future in building resilient and sustainable economy. I was surprised to hear that the participant reached 1,089. This is incredible. Big applause for Statistics Explore 2025. We are honored to have Professor Fabrizio Ruggeri, President-elect of the International Statistics Institute, a leading scholar in statistical science and Bayesian methods, whose contribution are widely recognized over the globe. He flew far from Milan, Italy, to share his research insight with us in the next lecture session. Thank you very much, Professor. Distinguished guests, ladies and gentlemen, we live in an era where data is regarded as the new oil and information as the new currency. This analogy highlights that data has emerged as one of the most valuable resources in the modern world, while the information derived from it has become a powerful driver for the modern economy. Every second, every minute, vast amount of data are being generated from social media, sensors, financial systems, and other domains. This ability, the ability to collect, process, and extract meaningful insight from those massive data sets is known as data science and big data analytics. It is profoundly changing the world. It is profoundly changing the way the world operates. From predicting the spread of disease that we together face in 2020 and managing natural disaster to driving innovations. Data science is refining how decisions are made, how businesses grows, and how society prepare for the future. In this sense, statisticians and data scientists play a crucial role, not only as analytics of numbers, but as architects of knowledge. Therefore, I believe that the Statistics Explore 2025 is a great event annually organized by a great student from the Department of Statistics that can enhance academic excellence and expand our global network, which is a crucial step for becoming a world-class university. Finally, I would like to express my appreciation to the organizing committee, our distinguished speaker, and all participants who have made this event possible. Congratulations to the statistics students. You have organized the very great event very well. With that, in the name of Allah, the most gracious and most merciful, I declare that Statistics Explore 2025 is officially open. Thank you very much. Wabillahi taufiq walhidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Mohon maaf Bapak, kami minta kesediaan Bapak untuk tetap berada di atas panggung.
Hadirin yang berbahagia, agenda selanjutnya yaitu pembukaan Statistik Explore 2025 secara simbolis.
Selanjutnya, kami turut mengundang kembali kepada Ketua Forum Pendidikan Tinggi Statistika, and also we would like to invite Professor Fabrizio Ruceri to the stage, who will join our distinguished guests for the symbolic opening of today's event.
Kami juga mengundang Kepala UPTD Diskominsa Provinsi Aceh yang didampingi oleh Ibu Profesor Dr. Zurnila Marli Kesuma, SSI MSI, Ketua BPS Kota Banda Aceh, dan Saudara Heru Bagus Cahyo untuk melakukan pembukaan Statistik Explore 2025 secara simbolis.
Baik, Bapak Ibu sekalian, mohon bersama-sama memegang koin. Lalu masukkan koin tersebut ke dalam celengan yang telah kami sediakan. Dalam hitungan mundur. 3, 2, 1. Alhamdulillah, acara Statistik Explore 2025 telah resmi dibuka. Masih kami persilakan. Pengambilan gambar dimulai dalam hitungan 3, 2, 1. Baik, sekali lagi. 3, 2, 1. Baik, terima kasih kepada Bapak Ibu sekalian. Kami persilakan untuk duduk kembali.
Terima kasih banyak kami ucapkan kepada Bapak Ibu sekalian yang sudah bersedia untuk membuka acara Statistik Explore 2025 secara simbolis.
Next agenda, a group photo session. To the documentation team, please come to the stage.
Agenda selanjutnya, sesi foto bersama. Kepada tim dokumentasi dipersilahkan naik ke atas panggung. Foto akan diambil dalam hitungan 3, 2, 1.
Once again, 3, 2, 1.
Kami ulangi, 3, 2, 1.
Hadirin yang berbahagia, acara Statistik Explore 2025 disponsori oleh Badan Pusat Statistik Provinsi Aceh dan juga Lembaga Penjamin Simpanan. The next event is the lecture session by the President-elect of International Statistical Institute, Professor Fabrizio Ruggeri. Ladies and gentlemen, it is my great honor to introduce our distinguished speaker today, Professor Fabrizio Ruggeri. Originally from Italy, Professor Ruggeri completed his studies in mathematics at the University of Milan before continuing his postgraduate education in the United States, where he earned a master's degree from Carnegie Mellon University and a PhD in statistics from Duke University. He is internationally recognized for his expertise in Bayesian statistics with significant contribution to robust Bayesian analysis, inference on stochastic processes, and risk analysis. Over the course of his career, he has authored more than 150 scientific publications and 6 influential books, and he has served an editor for several prestigious statistical journals. Beyond his research, Professor Ruggeri has been deeply involved in the international statistical community. He has held leadership role as president of ENBIS, ISPA, and ISBIS, as well as vice president of EC. He is currently serving as the president-elect of the International Statistical Institute for the term 2023 until 2025. Now, without further ado, let us warmly welcome Profesor Fabrizio Ruggeri.
Acara selanjutnya, lecture session oleh Bapak Fabrizio Ruggeri. Beliau merupakan Presiden International Statistical Institute. Kepada Bapak, kami persilahkan.
Is it working? Perfect. Thank you. So it's a great pleasure for me to be here in Indonesia. It's been so far a couple of weeks, very, very intense, but I enjoyed them a lot. I enjoyed hospitality, the interest for what I'm doing, the quality of the people here, scientifically speaking, also, from the personal point of view. So I am the president-elect of International Statistical Institute, and in 3 weeks I will become the president at the end of the World Statistic Congress, which will be in the Netherlands. ISI is the most important statistical association worldwide. It is 140 years old. It has also a consultative status with the Economics Commission of the United Nations. We organize every year a World Congress. The next will be in Hague. Next will be in Busan in 2027. We have also regional conference. We had also one here in Indonesia many years ago. We have also a lot of associations under ISI interested in Bernoulli Society, mathematical statistics, education, official statistics, service statistician, environmetrics, computational, and business industrial statistics. So also we have an important part, which is the young statistician group. So for us, young statisticians are very, very important, very, very active. And I was very, very happy to see the activities of the young statistician here organizing this event. 1,089 people. That's really incredible. Also, the number of people attending my course on Bayesian statistics is quite a lot. I really, really appreciate the work that you are doing, especially the chair of this committee, all the other people in this committee. And also, I also am very thankful for the people in this university for the way I've been accepted, been treated here. It's incredible the way I've been treated. It's a great pleasure to be here. Now, let's talk about science. I would say this morning I started with my day with a weird thinking about when I go to the supermarket and buy things. What I'm saying about this one. I'm talking about statistics. Is there a perception of what statistics is doing for the society? Well, among us, yes. But what among the people? What about among the rulers, the stakeholders, the people who we can work for? Sometimes there is not such a perception. Let's go back to the supermarket. Well, when I go to my supermarket, I put my card, fidelity card, and I get a sort of a machine. And I use this machine to scan the barcode of all the products that I am buying. And then I go to the cashier, automatic cashier, and then where is statistics here? Well, the point is that some people are not stealing food. So they have to do some check. How do they check? Randomly. That is statistics. But exactly randomly. Not exactly. Because sometimes when I don't go there for many, many months, it's very likely that will catch me and ask me to do some control. Again, so it's statistics somehow guided by some other covariance. We know it. It may be probably what we call a logistic regression. I am a person that probably might have one of steam, but in any case, there is some randomness there. So that is statistics. But also there is now statistics in the way we are doing the controls. Before, they were asking me to open all my bags and they were checking all the items. It was a very expensive activity, taking a lot of time, harassing somehow also the customer. Now what are they doing? Just picking some items and checking if I scan the barcode of this one. This is a statistical procedure. So are the people aware that they are subject to some statistical process every day? That is what we should do. Also, what about the importance of statistics? I have to write a letter as a president. I will do that as a president of ISI because in the United States, there is a Department of Statistics which is going to be canceled. Why? The university has to save money, and then what they do, they cancel statistics. I discussed it with another vice president of ISI. The same is applying to Australia. So there is this perception that statistics may not be needed. And no, we know, but we have to make this more clear, and ISI is making something like this. Also, ISI is making clear that statistics has to be used in a proper way by politicians. Up to now, this year, we wrote 2 statements as ISIs about the US government. In the first case, we're doing something wrong about the financial budget, not using the proper data. In the second case, they fired the chief of the Bureau of Labor Statistics. What was her fault? She said the real numbers about laborers, the workers in the United States, which were not what the government wanted. And for 10 years, we are still close to the former president of the Greek National Statistical Office, who did another great mistake. He said the Greek economy is doing very badly, and the government did not like it. So statistics is very, very important, and we have to a mission in some sense to show that statistics is important at all levels, and we have to do good statistics and show it. Also, I was presented as a Bayesian statistician. Yes, I am a Bayesian statistician. And I think all of you, although you are thinking you are hardcore frequentist statistician, you are a Bayesian in your mind, in your heart. Why that? Because you came here with an opinion about me, an opinion about this event, and that is your prior opinion. And now you are collecting data. You are going to listen to my talk, the talk of other more important people who are saying something more interesting than what I'm going to say. At the end of the day, you will have a different opinion about me. Maybe you will say, this is a very boring person. Why did he come from Italy just to bore us? We should have stayed at home without listening to him. Or, well, it's been very inspiring. But in any case, you will have updated your opinion. And we, as the Bayesians, are doing something like this. We use the Bayes theorem to combine what we get from the data and what is our opinion. And we update that. That is what the Bayesians are doing. You know, also about the same event, we might have different opinions. I saw a flyer about my talk. Well, speaker from Italy, as if it was an exotic place. If you think that I ever thought in my life that Italy was an exotic place, I thought of Indonesia as an exotic place, not Italy, but for you is the opposite. So the same thing is, you have different perception. Now, let's go back to my talk. So I'm talking, I said the title is The Last of the Mohicans. Probably you never read this book. I never read, but I'm fully aware of that because it was very popular when I was a kid. It's about the last, what we call Indians. Now we should be politically correct, call it Native American. It was the last one whose father and mother was a Mohican, this kind of Native American. And yes, what am I? I am a stochastic modeler. I am a statistician. In the era of artificial intelligence and machine learning, I still here doing work as a stochastic modeler. Am I the last of the Mohicans? Well, I just checked on Google. There are 1,500 Mohicans nowadays. So I'm not the last one. So there are still some people. So there is some hope for statisticians to survive. What I'm going to do now, I am just presenting some quotes. And then I'm saying some words about what can we do, what's happening in these days in which we have statistics, machine learning, artificial intelligence. I would like to be clear. I'm not against machine learning. I'm not against artificial intelligence. I think we can provide different perspectives and also cooperate a lot. And that will be the points I will make in some of the examples I will present later. So now let's start with some of the quotes I found. They are from a paper that I prepared for the journal, which I've been editor-in-chief for 17 years, applied stochastic models in business industry. If you look for this paper, you will get it for free because it's open access. So some quote. Now I have to make unhappy the dean, but you already read this quote yesterday when we were having some Sanger. By the way, I appreciate a lot Sanger, okay? That is something I like a lot from this country. From this, not country, from this place in Aceh. That is, I was told it's just Aceh. So we can stop looking for models. We can analyze the data without hypothesis about what it might show. We can throw the numbers into the biggest computing clusters the world has ever seen and let statistical algorithms find patterns where science cannot. So that means we don't need statistics. We have data, the computer do everything. Is that my opinion? Of course not. And then let's go about, this is the 8-9 times I'm quoting George Box. But this is something that every statistician has to quote in his life or life, which is all models are wrong, but some are useful. The point is that there is a point of view of a computer scientist where Peter Norvig says all models are wrong, and increasingly you can succeed without them. Okay, my point is false. I disagree with this. And just to conclude, there is this sentence by a very famous Italian physicist, Carlo Rovelli, and in his book, one of the co-authors of the paper in other Italian, per Cesare Secchi, translated it is the one. The goal of science is not to make predictions. It is also offering an image of reality, a conceptual framework for thinking about things. This ambition has made scientific thinking effective. If the goal of science were only predictions, Copernicus would have not discovered anything compared to Ptolemy. His astronomical predictions were no better than Ptolemy's, but Copernicus found the key to rethink everything and understand better. Think carefully about this sentence. So, my talk today will be about giving some suggestion, something to think about, sort of mission of you young people involved in statistics for what to do in the future. So let's move to the next one. And so there are, as also the Dean mentioned, there's been a lot of development about analytics due to artificial intelligence, machine learning, deep learning, a lot of data, big data. We are in this world. But there is also a question, which is there a future for what we used to do as a statistician? As editor-in-chief of this journal, I saw changes over 17 years. We started with a lot of work, only work on stochastic models. At the end, I had a lot of submission using deep learning, other machine learning, neural networks, and other methods. At that point, I asked myself, is there a future for us? And that is the paper that I was mentioning. And here I have just some ideas coming from that paper. Some are mine, some are some of my co-authors. So I would say I'm not against artificial intelligence. I'm not against machine learning, but I recognize their role. But I would say, how can we survive together, work together in this world? Because our goal should be to find a proper methodology for assessing the right balance between purely data-driven empirical methods, something like machine learning and similar, physics-based models, and probabilistic stochastic models. So that should be, in some sense, the mission that we have, that you have in the future. Put together these three different, these three different aspects of that, because this is necessary for effective and robust achievement of data-driven knowledge. We have a lot of data, we want to get knowledge. And these are the combination of these three methods, approaches, all together is the way we can go. Next. So the point is, machine learning often uses deterministic methods. Well, going back to deterministic methods, 3 weeks ago, I was teaching in Italy, in Trieste, at the International Center for Theoretical Physics, and there was a mathematician who said, all the world is deterministic. Well, I told the students, let's wait for my class, I will tell you the story, the true story. Because, well, he said, if you know everything, if you know exactly what's all the laws of physics and so on, we can predict everything. Yes, okay. But let's talk about real life. In real life, everything is stochastic. So we have to do something like that. But the point is, many methods in machine learning are deterministic. But what about what statistics is offering? We can model uncertainty. We can model also reliability. So we are interested also in the reliability of what we are getting. So if we change a little bit, what's going to happen? You have to think about the people have to make a decision. They have to rely on something which is reliable. Also, this is an important aspect, explainability. A stochastic model can explain what's going on. A machine learning, not yet. But they're working on this. There is explainable artificial intelligence. Also, there is an important aspect about sample size. Well, we are talking about big data, but to have some machine learning algorithm working well, we don't need big data. We need big data, a lot of them, to make it reliable. And often we don't have this big data. So then again, we might miss the possibility of using something in statistics. Let's go next. And then, so for example, if we would like to make a forecast about, for example, the conditional mean of a stochastic process, there is a lot of data set. Well, machine learning methods can be a first choice. That would be a great idea. But if you want to understand the way the data were generated, when we have to think about the model which is behind them. And that is the point in which the classical stochastic modeling can be useful. Also, we have something which is called design of experiment. Once we did something like this for the Italian electrical state company, they were trying to put meters in the houses that could be read from far away. So what we did was to create different areas with different combination of electrical tools, computer, fridge, and so on. And we tried to make an experiment, not all possible combination, but reduce the combination so that we could understand if we could communicate with these meters. So we have this part, which is something which currently machine learning cannot do very well. Okay, so this, if you are interested, this is something you could do. It's randomization, replication, and blocking. So dividing different items according to their characteristics. Also, sample survey. I don't know if this country you have a census. In Italy, we used to have every 10 years. Now we are collecting data only randomly, smartly. So there are a lot of issues about bias selection, people are not answering and so on. Well, can machine learning deal with this one? For sure, statistics can do it. So we have something that we can think about what statistics can offer and also what machine learning can improve. For example, these are two examples. Let's go further. I guess I have 1 hour more or less, which means 45 more minutes. Is there a chair of a session? Yes, 45 minutes more. Okay. So now, well, if you want to do something new in machine learning, do something about survival analysis. Survival analysis as proved by this person, Vigrebe and others, and you can see this website. They say there is not much about sensor and concrete observation. And this is something that is possible to do, new kind of research. Also, if you look at the probability of a default of a bank or of a community, then a machine learning algorithm could be useful if you are thinking about a particular customer. Is that customer with that characteristic as a job, as a house, and so on, one willing to pay back a mortgage or not? But if you think of the entire population, then machine learning is not doing a proper job. Then you have to go back to statistics. So this is just pointers about possible areas in which you could try to think of work. There is a lot of work to be done. Let's go next. Now I'm going to present 5 works I've done in my life. Each one of them has some characteristic. And now let's forget about this slide. Let's go next. So let's start with this. I already gave this talk a few days ago, but now you will see. Let's go next. Next, healthcare frauds. So what is the issue here? What is the message here? The message here is that we have to communicate with practitioners. We have to communicate with people who are not aware of statistics. How can we do that? Well, you may see histograms, pie charts, and other tools. Okay, this is one way. But what we are proposing with our works with some people in the United States is the following. Let's use some sophisticated tool which allows us to provide something simple. So sophisticated statistical tool providing something simple interpreted by the people. What is the issue here? The issue here is the following. There are a lot of waste or abuse or frauds in healthcare. For example, some doctors are maybe charging too much for some exam or others, or prescribing something which is not appropriate just to get more money. So we have to do something to see if there is some anomaly in the behavior of a group of medical doctors. Can we use machine learning methods? Well, they're sort of black box. Can we use well-established method like logistic regression? Yes, but if you already know the pattern of the possible fraud. In this case, we are going to do something which shows anomalies, and you will see how it works. So the idea is this one. There is a group of medical doctors which are behaving in the same way, and the goal is to see if a particular doctor is behaving in a different way with respect to his group. So let's go next. And this is a tool which goes back to 1905, Lorentz curve. It's used in economics. What is this? This is a tool which allows to measure the inequality in the distribution of wealth in a population. How do I read this curve? Well, let's see the curve in the bottom. The curve in the bottom is the following. We have a population made of 3 people, and let's compare the curve in the bottom and the straight line. We have a population made of 3 people. If the 3 people had the same amount of money, what will be the curve? And how do I build the curve? I build the curve in this way. I start plotting on the x-axis the percentages of poor people. And you can see, I'm sorry, I don't have a laser pointer, but let's see here. So, point here. What does it mean, this point? This point means 1/3 of the population has 10% of the amount. I don't have a laser pointer. I cannot move arrows and so on. It's a pity. So this is a situation in which, look at 01, 03, 06. It's a situation in which one person has 10% of the money, one has 30%, and the other is 60%. I want to see if there is inequality or not in this case. So I plot on the x-axis the first one, the poorest person. How much percentage of population does he represent? 1/3. How much money he has or she has? 10%. So it will be X 1/3, Y it will be 0.1. Now, let's take the 2 poorest people. They have 10% and 30%. How much do they represent of the population? 2/3. So on the x-axis, you go to 0.66, and the y-axis, you go to the sum of the two, 0.4. And you get the curve below. If I had the same amount of money, you could get the straight line. So this is a graphical tool showing you if there is inequality or not in a population. The closer the curve is the straight line, less inequality there is. Far away, measures for that to twice the area or the maximum distance. So this is the way. We can think of as a comparison between discrete measures. But now let's go next one, and then I will skip the mathematical details of this one. I just want to go. Who should I look for changing? Okay, let's forget about this one. Let's go next. Okay, next. The idea here is this one. Well, I think, I don't know if my slides are available to everyone. I hope they will be made available. So here the idea is this one. There are a group of medical doctors. No, sorry, the previous one. Previous one. Back. Oh, no, next. Okay, this is. So there is a group of 30 medical doctors in diagnostic radiology in Vermont. And then they're prescribing some X-ray. We think they are similar. But now we are doing the following. we are comparing how much a particular doctor, call it MD1, medical doctor 1, is prescribing respect to the rest of the group. Here you will see some numbers. This 965, 965 and 19%. What does it mean? What does it mean, this one? It means the following. This person, okay. So this person is prescribing this particular exam, the X-ray of abdomen, 9 times more than the group he belongs to. And this represents roughly 20% of his prescription. So this is an anomaly. And this is the first warning that we can send. Now, let's move to the next slide. Look, this is a curve which is similar to the previous one. How do I read it? I told you, behind there is a very sophisticated tool called concentration function. It's very sophisticated, mathematically speaking, is tough. But here is a very simple representation. How do I read the curve there? Look at the curve in the bottom. I read it this way. You can see it's equal to 0 up to 0.5. What is the interpretation? It means that this doctor is not providing exams that represent the 50% of what the population of doctors is giving. So this, you can see the line which is at the bottom from 0, 0 to 0.5 is essentially 0. That is the interpretation. So you can see here, let's think about someone in charge of detecting frauds. By looking at this graph, he can tell, she can tell that this doctor is very different from the others because he's prescribing something which is very, very different. And then looking at the next slide, so no, sorry, forget. Back, sorry, adjust. So we have some indices which are relevant, which are twice the area of between the two curves, and one is the maximum distance. There are indices due to two Italian persons, also the concentration function to other Italians, so Pietra and Gini. But then we have these indices, which are to be, if a doctor is behaving like the rest of the population, the number should be 0. But look on the right side. There are 7 doctors which have a large value. Again, these might be doctors which are behaving in a strange way, anomalous, not a fraud. We are not able to say this one. So the take home of this message is try to use your knowledge, even sophisticated methods, to communicate to practitioners who are not able, are not expert of statistics, to communicate some findings by using statistical methods. I was a few weeks ago in Milano at an exhibit. It's called Uncertainties, and there was a lot of data, graphical representation of data for ordinary people. It was a very nice one. Let's move next. So this was the, no, sorry, also this one. So let's forget about this one. I don't have much time. Now, this is another tool that we can present about these people, which essentially is saying, sorry, since I'm here. So this is data collected over 5 years. We took the mean of one of these indices and we took the standard deviation. So, well, how can a practitioner read this one? This doctor have a mean equal to 0, standard deviation 0. They behave always like other doctors. This one have a maximum value of discrepancy and standard deviation 0. That means they're always different from the other. So this is another. But now let's move to something else. Next, please. Next. Now, so that was let's communicate with practitioners using our tools. Now it's a different topic. Now the topic is let's work with other people. Here is a job we did with some biologists in Italy. And also the other relevant aspect of this talk, of this part, is how to use a stochastic model to describe a physical problem. And now this is the following. We had an island, well, we have many islands, not like in this country, but we have an island, and called Sicily, in southern part of Italy. There was a strawberry field. There was an animal eating strawberries. So instead of putting chemicals, the biologists put another animal. So this is so-called methods called prey-predator method. There is a prey, there is a predator. There is a method called a model called Lotka-Volterra. It's named after Volterra. Volterra was the first president of the institution for which I work. He was a mathematician. And look, what does this mean? This is a mathematical model. It means the following. We are considering the mass of the prey, X, the mass of the predator, Y, and we normalize between 0 and 1. How do I read this, which is a ordinary differential equation? dxt is the increase of the mass of the prey at time t, is a function of r, which is the specific growth rate of the prey, times the mass xt. But then what we had to do? Well, then the amount of strawberries is not infinite, is limited. So if the number of the prey is increasing, then they don't have much to eat, each one of them. So if they are increasing, we have to penalize in some way. So we put 1 minus xt. But that is the activity of the prey without a predator. But then there is the predator. And so that is related to relation between xt and yt, and qt, which is what we are interested, is the functional response of the predator, how good the predator is in capturing. So you can see we are talking about a physical process and we are translating into mathematics, this one. Second equation is the increase of the predator, which is somehow related to its capacity in capturing, but also the production rate of the predator, how it's reproducing itself. But then there is also a predator of the predator, also natural causes, and the predator is dying. So that is a mathematical model. You can study this one. The point is, we do not collect data exactly. We do not collect the data exactly, so we have to introduce some uncertainty. And here you can see Qt equal to Q naught plus sigma, a white noise, Gaussian white noise. And what is the result of this one? Next slide. We have, now we are introducing statistics. We start from a mathematical model, now it transforms into a stochastic differential equation. And look, stochastic differential equations are very, very important for a statistician. For describing a lot of physical problems, they are very important. So that becomes a Wiener process with the change, and that is affecting the interaction between the two prey and predator. But then we had to add another Wiener process affecting both of them separately, because and here is the role of the biologist. Why are we introducing this one? Because there is a demographic stochasticity, variability in population growth, but also environmental stochasticity due to sampling errors and different birth and death rate in different periods. So again, this is another important measure about the statistician. We have a lot of models in our pockets, and when we go to chat with a biologist, a medical doctor, an engineer, we go there with our models. But then we start listening what the biologist is saying. At this point, we are willing to change also our model, to learn. So this is other part of our job as a statistician. Speak with other people in other communities and cooperate and learn from them as well, so that we can get also new models. And that's what we did in this case. And then what else we have to do? Then now we have computational aspect. Well, we have the mass between 0 and 1, but all of that is working well if we are in the real line. So what we did, we consider a function which is essentially equal to 1 in the between 0 and 1. It goes to 0 elsewhere, but it has to be smooth. And then we put something like this. Also, do you think that was easy at this point? No, because also we have computational aspect. So another important aspect for statisticians nowadays is to handle also computations. We have to be able to do computations. That is very, very important. And what we did here was the following. How can we solve this from a statistical point of view? Well, we can do approximation. Also, numerical analysis is quite important in this case. We have to do approximation. So transform the Wiener process in Gaussian increments. And then we are able to write the likelihood. In this case, we are able to write the likelihood. But we have an approximation which works well if the points are very close. It's called Euler-Maruyama. The point is that we didn't have very close point. So what to do? Generate fictitious point in between. So there are also computational aspects. And then there are algorithms, Markov chain Monte Carlo if you do Bayesian, or expectation maximization if you do others. So this is an example in which of cooperation with others, learning from them, constructing a model corresponding to physical problem involving knowledge of mathematics, in general, ordinary differential equation, numerical analysis, computation, and of course, statistics. So this is what we have to, this is the world nowadays. We have to work with this knowledge. Next further. And now you will see the result of, next. So this is the result that we got. On the top, there is the evolution of the population of the prey, on the bottom of the predator. You can see at the beginning there are no predator. Actually, they found no predator, but then they appeared. Why they did not find? Because it's very difficult. We're talking about something which is very, very small. But then the prey goes up, but then the predator starts eating the prey and goes up, and the prey goes down. But at this point, there is no more, but the predator goes down. As a statistician, would you like this fit of this data? The stars are the data. As a statistician, you would not like it. But as a biologist, they said, great, we never got something so close to our data. But that was not enough. We did another model. Look at the next model. Next slide. Look, here we got very, very close. So this was a very satisfactory. So ordinary differential equation becoming stochastic differential equation. Now let's move to another one. This is my yesterday talk. Now, this is an interesting problem in which we have data, but not like we would like to have data. So this is something else you have to think about. This is another computational aspect. A lot of work nowadays in statistics is about having efficient computational method. That is the point. Addressing complex problems. And this is one of them. People arriving at the airport, A1, A2, A 29, at the gates. People are arriving randomly. Then they are disembarking. There is a random distribution about that. Then there is a camera counting the number of people going through the different points. Then the people are walking to immigration control. So this is an international airport. Actually, it's Brisbane, Australia. And then when they arrive in the immigration area, there is another camera, the red one there. And then the people have to choose, more or less independently, if to go to manual gate or smart gate. Australian can go to manual gate, smart gate. Also other people, Italians can do also that. Not all people can go to a smart gate. And then there are other cameras collecting this one. Well, are we able to build a model out of this? Well, if I could follow a person, yes. Because let's go to the next slide. Next, sorry. Then I come back to next again. Sorry. Okay, now we are able to build. If I am this person, There is a gamma distribution for my disembarkation times, a gamma distribution for time to immigration control, a Bernoulli distribution for being national or foreigners, a Bernoulli distribution for selecting smart or manual gates, an exponential distribution for service time depending on the selected gate. So this is, I would be able to build a likelihood. And as a Bayesian, I would be able to build a prior. But what is the problem? I would be able to do this if I could follow each person. But what are my data? The number of people going through, exiting from gate H5, the number of people entering immigration, but I cannot follow the people. So what is the problem here from a statistical point of view? There is no likelihood. We are used to do inferences by using likelihood, classical or Bayesian by using likelihood. Here there is no likelihood. And this is something which is very challenging. This is something which is a problem nowadays, dealing with something which we don't have the likelihood. There are a lot of computational methods. The one we use here is called approximate Bayesian computation. What is it? We simulate data, and we want to see if the simulated data are close to the actual ones. That is the point. And then out of that, we get our methods. So essentially, the message here is the complexity of the problems that you have to face right now nowadays is getting more and more greater, more complexity. Often we cannot use the traditional methods of statistics, which are likelihood estimation, maximum likelihood estimation, or Bayesian estimation. We have to use some computational tool, variational Bayes, approximate Bayesian computation. This is something that could be of interest for you. Working on something which is computationally efficient. This is the new area of research. But now there is another one. I want to go next. Let's forget. No, sorry. Yes, go next. Let's forget this one. And then, what is a statistician doing? Well, as I said, all models are wrong, some are useful. But at some point, we have to check if our model is doing well. What is an example of checking? In our case was this one. We have the real data, the black one. And by using our model, we build some prediction about the real data. And you can see they are very, very close. So our model is good in predicting the actual data. So it's a good one. But then, go next. Let's suppose that something wrong occurs in the airport. Let's go next. Next. So let's suppose that a flight is delayed 15 minutes. What is our interest here? Our interest here is the following. We would like to know what is the length of the queue for the passengers, how much they have to wait, and what's going to happen. If one flight is delayed by only 15 minutes, at 10:50, you will see the data later, the waiting time will go between 28 to 71 minutes. And the median queue length will go between 146 to 363. And then what are we suggesting? Let's take 2 new officers to work in this time. You will see what's happening. There will be a reduction of the waiting time, 41, and the passengers, 319. So next slide. So here on the top is the red curve should be a band around the waiting times at the manual gates. That should be the one if a flight had arrived on time. On the vertical lines, you can see the arrival times of the flight and the size of number of people in the airplane. But then in the one in the middle, you will see the second vertical line moved. That means 15 minutes delay. Look at the change at the prediction about the waiting times. And then in the bottom, introducing 2 officers, you can see it will improve in some way. So this is the goal here. So here, what we are using were some problems, some methods, cues, computational aspect, but also decision. Another important area in statistics is also related to decision analysis. That is something which is very relevant. And now you will see an example. The next slide is about essentially cybersecurity. Cybersecurity is something which is very, very relevant. Let's go next. Adversarial classification. So the point is this one. We can go next. That's okay. So we can go even next. That I will say just in word. So this is the issue. I received the other day a message from the president of my association telling me that one of our colleagues, a member of our council, was had to go to Milano because her sister had died in Milano and she was stuck in Philippines from Singapore, and I had to help her in some way. Well, it was a very nice message. The point is, it was sent from a strange address. I looked this one. Also, the president was signing himself as ISI chair. We usually say ISI president. At that point, I said, no, this is not a good message. So what is the issue here? Sometimes there are people trying to fool you, for example, convincing you that a message is a legitimate message and you can send money somewhere else. In general, there is an issue which is relevant nowadays, cybersecurity, the attack to our information system. And the idea here is classification. Well, machine learning is doing a lot of job about classification. Based on a lot of features, you can classify if a person is a good person or not paying back a mortgage, if it's a spam message or not. But there is another issue which is less treated, which is if someone is trying to fool you, what you should do. This is called adversarial risk analysis or adversarial classification. This is another area which is very relevant, related also to Bayesian decision analysis. This is something you can think about a possible work in your life. So here the idea would be the following. I'm not entering too much in the details, is there are some messages, objects which are either malicious or innocent. And based on their type, on the features, X, you have to decide if they are of one type or the other. Typically, machine learning methods are doing the following. Training so that you will be able to have an algorithm which will tell you for new data if they are malicious or not. The point is that this is machine learning, but then you have to think about possible attack. And this is an area which is the one in which the first one I'm talking about, cooperation between statistics and machine learning. This is called adversarial machine learning. So using machine learning methods combined with Bayesian decision analysis method to deal with promise of adversary attacking a person. And here, let's forget about the details. So the details essentially is, let's go next to the next slide, is this one. So this is the situation. There is a feature Y, a classification Y, so malicious or not, which implies some feature X. Then there is an attacker, which is making a decisions A, transforming the features X prime. If I'm talking about a person paying back for a mortgage, instead of writing that this person is unemployed, I will write this person has a job paid 100,000 euros every year, okay? Or something like that. Modifying the data, try to convince me that this person will be able to pay back the money that the bank is borrowing. So at this point, what is this one? The classifier has to make a decision, if it is a good or not, malicious or innocent. And what is involved here? A utility function. What is the utility of this person in classifying in that way when the true value is that one? And there is also a utility here for the attacker based on the cost of his attack, the real value of Y, and the decisions by the classifier. So this is, in a very simple way, a problem that you can address. Let's go further. Okay, this is just the mathematics behind. Let's forget about this one. let's forget about this one. So these are the methods. What we have done was this one, trying to show that our methods based on combination of machine learning and decision analysis was doing better than a traditional methods in machine learning called naive Bayes. What's happening? We have some data, some of them are spam, some are not, and then we are modifying some of this data and we want to classify correctly. And we compare our method with the method naive Bayes, and you will see next that we are doing definitely better. So what do I read there? Well, there is some variance involved, but you can see on the top is our curve, and on the bottom is the naive Bayes. How do I read this one? Based on our approach, we repeat it many times. 95% of the time, we were able to do the right classification despite someone changing a little bit our data. Naive Bayes was working well 75% of the time. So this is one way of cooperation between traditional methods in statistics, Bayesian decision analysis, and machine learning to improve the results. And now you will see the last one. Let's move later. Gate data. So this is a paper that we just published. Is about the following. I don't know if you're aware about wavelets, but we can represent function by using wavelets, but let's move next. So this is a very famous wavelet basis due to R, although it was not called. It is the following. Every function which is continuous in the interval 0, 1 can be written as a mixture of these bases. And there are some coefficients there. If you go next, I will show you what I mean by this. Okay, so you have a function in 0, 1, a continuous. How can I represent this one? Well, there should be a function which is the average of this one, which is a function between the uniform one, and you multiply by the mean of this signal. And then you have to do the following. The first on the left, you have this is a wavelet in which you represent the function, the continuous function, as the one on the left, which is equal to 1 up to 0, up to 1/2 equal to -1 in the second part, times a coefficient, plus the second one, you can see psi10 times a coefficient, plus psi11 times a coefficient, plus psi20 times a coefficient, and so on and so on. These are repetition of the interval 0, 1. So the idea here is to write a function as splitting as a sum of an infinite number of functions, of bases, orthonormal bases, mathematically speaking. But then let's go next. We have a stochastic process which is self-similar. What is the notion of self-similar? You can see the second line. X of lambda t is in distribution lambda h of x of t. Well, using our methods, I skip the mathematical details. We are able to estimate this parameter h called R's parameter, and then you will see from a point of view. So this is sophisticated methods, but now you will see how we can combine machine learning and this stochastic approach. Let's go next. Okay, forget about this one. So these are data. These are data about elder people who are falling. So we want to know if these people are behaving in terms of falling or walking. Data are not collected by us, but there are walking tests like this one, 4 meters at usual speed, or someone rising from a chair, walking 3 meters, turning, returning, and sitting back, or 30 minutes with someone at the feet, on the shoes, measuring the behavior of this person. And the one in these shoes are something which is called linear acceleration and angular velocity. And this is something which we proved to be something called fractional Brownian motion, actually Gaussian noise, but doesn't, Gaussian fraction noise, but doesn't matter. So we have this one. So there are these which are the features which have been considered by the other papers. The people consider other papers. They try to find out what were the best way of predicting if person are falling or not, because that is the goal. The goal, based on the way they walk, we would like to know if they are more or likely to fall or not. And then they used machine learning methods by using these features. But then we also used our approach. We did the following. We compared, let's go further. Next. So we compare our method with logistic regression, support vector machine, k-nearest neighbors, naive Bayes, random forest, and ensemble model, which are typical machine learning. Well, logistic regression is essentially statistics. Are methods in machine learning to make forecast. Forecasting if a person is falling or not. What we have done, we divided, as usual, the group of people in two groups, testing and training and testing. So we used our approach to train our algorithm, and then we used data for which we know if a person fell or not, and we compare if our algorithm was predicting right. And now you will see what's happening. Let's go next. Okay, now we have three comparisons. These are the 6 methods that we used. One is the traditional way, only the machine learning. One is the traditional way of estimating the ask parameter using wavelet. The one on the bottom is our way. What are these numbers? These numbers mean the following. When you do this operation of splitting the data that you know in 2 parts, repeating many, many times, so that you train the algorithm. For example, you train the random forest, and then you apply to the other data to check if you are able to make the forecast right. With the random forest, you get 48.28 times right. So 1 times after 2, you make the wrong classification. So it's not very reliable. But when you go with our approach, so combining in this case machine learning and statistics, you get 89-65%. Now that is the message. Let's cooperate. Let's go further, and we are close to the conclusion. Okay, so there are communities which are evolving. So the idea is maybe take different approaches, machine learning, stochastic, and also cooperation in some way. Also, statisticians can provide practitioners in machine learning with knowledge about biases, knowledge about missing data. Also, people in machine learning reinvented the wheel, like the principal component analysis. But it's been studied for a long, long time. But we have to not to be afraid to work in this field. Let's go next. And so statistics is still a powerful tool for problem formulation. And machine learning is very important for prediction in some sense. So we have to cooperate in some way in terms of evaluation of uncertainty, interpretability, model stability, and reproducibility. This is something which is really, really important. And then let's go next, which is, I think, is the conclusion. These are some of the paper. The first one is the one about this discussion about the future of stochastic modeling. Second and third are about the healthcare case. Fourth and fifth are about the predator-prey, sorry. Next, the first 2 are about the airport. The second 2 are about the adversarial risk analysis, and the last one is about this gate data. So the message I want you to take home is that I think there is still work for statisticians. I try to tell you possibility of possible work, how we cooperate, we work with others, but also we have to cooperate with machine learning. We have to learn each other, and this is the take-home message. Thank you.
We would like to invite Professor Ruggieri to stay on the stage as we will continue with the awarding of the plaque. Please, professors. Stay. Okay. We now invite our Dean, Professor Dr. Taufik Fadiabidin SSIMTech, to hand over the plaque. To our Dean, we kindly invite you to the stage.
Dalam hal ini, kami mohon kesediaan Dekan Fakultas Matematika dan Ilmu Pengetahuan Alam Universitas Syah Kuala, Profesor Dr. Taufik Fadiabidin SSIMTech untuk menyerahkan plakat. Kepada Bapak, kami persilahkan. Kepada tim dokumentasi, dipersilahkan. Dokumentasi akan diambil dalam hitungan 3, 2, 1.
Once again, 3, 2, 1. Okay, thank you. Next, we kindly invite Professor Dr. Taufik Fadiabidin SSIMTech and Professor Fabrizio Ruggeri to return to their seat. Let us once again express our deepest appreciation to Professor Dr. Taufik Fadiabidin and Professor Fabrizio Ruggeri.
Terima kasih kepada Profesor Dr. Taufik Fadiabidin SSIMTech dan Profesor Fabrizio Ruggeri.
Now, let's take a look at Statistics Explore's opening video.
Selanjutnya, marilah kita saksikan pemutaran video pembukaan Statistik Explore 2025.
Selama puluhan tahun, stabilitas ekonomi sering diukur melalui indikator makroekonomi nasional, seperti pertumbuhan produk domestik bruto, inflasi, dan tingkat pengangguran. Di tengah perkembangan teknologi dan tantangan global yang semakin kompleks, peran Big Data menjadi sangat krusial. Dengan kemampuan Big Data dalam memproses, menganalisis, dan menginterpretasikan informasi yang masif, inovatif, dan adaptif. Indonesia sebagai negara dengan potensi besar di bidang teknologi dan inovasi lokal, memiliki peluang strategis untuk meningkatkan ketahanan ekonomi melalui pemanfaatan Big Data. Dengan Big Data, pemerintah dan sektor swasta kini dapat merancang kebijakan yang lebih responsif terhadap kebutuhan masyarakat, mengidentifikasi risiko lebih awal, serta menciptakan solusi yang tidak hanya efisien tetapi juga berkelanjutan. Oleh karena itu, Himpunan Mahasiswa Statistika dan Departemen Statistika Universitas Syah Kuala menyelenggarakan Statistik Explore 2025 dengan tema Economic Stability Through the Power of Big Data, Innovative Strategies for Building a Resilient and Sustainable Economy, sebagai wadah eksplorasi, kolaborasi, dan penyebaran ilmu dalam membangun perekonomian yang tangguh dan berkelanjutan berbasis Big Data. Seminar Nasional. Seminar nasional ini akan menggali potensi pemanfaatan Big Data dalam mendukung ekonomi digital, UMKM, dan inovasi lokal. Selain itu, terdapat sesi bedah buku, seleksi variabel pada permodelan prediktif statistika dan machine learning yang akan dipandu langsung oleh penulis buku. Student Forum. Student Forum bertujuan mengembangkan hasil riset dan analisis mahasiswa yang berkaitan dengan statistika, ekonomi, dan teknologi data. Videographic Competition. Kompetisi mahasiswa yang menggabungkan antara visualisasi data dan storytelling dalam bentuk video pendek. Data Science Competition. Kompetisi mengolah, menganalisis, dan mempresentasikan data dalam konteks ekonomi dan sosial yang relevan. Big Data Competition. Kompetisi untuk menyelesaikan masalah dengan menggunakan Big Data yang berfokus pada ketahanan ekonomi, keberlanjutan, dan inovasi teknologi. Pelatihan Software. Pelatihan penggunaan perangkat lunak untuk analisis data ekonomi dan statistik, khususnya dalam materi seleksi variabel. Dengan total hadiah sebesar 19 juta rupiah. Oleh karena itu, Statistik Explore 2025, Economic Stability Through the Power of Big Data, Innovative Strategies for Building a Resilient and Sustainable Economy, mengucapkan terima kasih kepada para sponsor, serta kepada seluruh media partner.
Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين، حمدا شاكر حمدا يوافي نعمه ويكافئ مزيده. يا ربنا لك الحمد كما ينبغي لجلال وجهك الكريم سلطانك. اللهم صل على سيدنا محمد وعلى آل سيدنا محمد، والحمد لله رب العالمين. اللهم إنا نسألك سلامة في الدين والدنيا والآخرة، وزيادة في العلم وبركة في رزق، وتوبة قبل الموت، ورحمة عند الموت، ومغفرة بعد الموت. اللهم هون علينا في سكرات الموت والنجاة من النار، والعفو عند الحساب. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا هب لنا من أزواجنا وذرياتنا قرة أعين واجعلنا للمتقين إماما. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا تقبل منا إنك أنت السميع العليم. حسنة وقنا عذاب. سبحان ربك رب العزة عما يصفون، وسلام على المرسلين، والحمد لله رب العالمين. الحمد لله رب العالمين. السلام عليكم ورحمة الله وبركاته.
Ladies and gentlemen, with the end of the prayer reading, our program for today also ends.
Hadirin yang berbahagia, dengan berakhirnya pembacaan doa, maka berakhir pula acara kita hari ini.
I am Ratu Suci Nurul A'la and my partner Imam Adli. We apologize for any mistakes and thank you for all your attention.
Saya Imam Adli dan rekan saya Ratu Suci Nurul A'la pamit undur diri. Mohon maaf atas segala kesalahan dan terima kasih atas segala perhatian. Wabillahi taufik wal hidayah.
Wassalamualaikum warahmatullahi wabarakatuh.
Seiring dunia yang semakin terbuka dan perkembangan era yang sangat dinamis, setiap individu dituntut untuk memahami dengan cepat dan tepat fenomena dan data-data yang tersaji secara tiba-tiba. Sementara itu, perkembangan pesat teknologi informasi dan komunikasi telah menyajikan miliaran data-data baru yang tidak mudah untuk dianalisis dan dipahami. fakta ini memberitahu kita bahwa era big data saat ini sedang sangat membutuhkan sumber daya manusia yang mahir dalam bidang statistika. Kebutuhan ini bahkan semakin tinggi di masa depan, seiring aktivitas manusia yang semakin berkembang. Fakta inilah salah satunya yang mendasari lahirnya program studi statistika Fakultas MIPA Universitas Syah Kuala pada tahun 2012. Program studi ini lahir sebagai program studi statistika pertama di Pulau Sumatera. Visi program studi statistika sangat realistis namun bertenaga, yaitu menjadi pusat keunggulan pendidikan dan penelitian statistika dan aplikasinya di Pulau Sumatera yang berakreditasi tinggi secara nasional dan dikenal secara internasional pada tahun 2025. Perjalanan program studi statistika menuju pencapaian visinya ini terlihat berada di trek yang benar. Selain itu, program studi yang bernaung di bawah jurusan statistika ini juga sedang mempersiapkan program studi baru Magister Statistika dan Data Science. Visi mereka sama sekali tidak naif, mengingat fasilitas yang dimiliki jurusan statistika saat ini sudah sangat memadai. Apalagi sumber daya manusianya adalah para doktor atau master lulusan Amerika, Belanda, Jerman, Inggris, Taiwan, Malaysia, Thailand, dan tentu saja Indonesia. Bahkan ada di antara mereka yang sudah bergelar profesor atau sedang menunggu persetujuan untuk gelar guru besar mereka.
Kami sangat optimis dengan prospek jurusan statistika USK, apalagi kita sedang dihadapkan dengan era data dan kebutuhan akan data. Speak with data menjadi isu sentral yang diperhitungkan di lembaga manapun saat ini. Dan di masa depan, urgensi data ini akan semakin menguat. Dengan potensi yang jurusan statistika USK miliki, serta sumber daya yang kami punyai, insya Allah sepenuhnya kami yakin para alumni jurusan ini akan sangat dibutuhkan oleh semua lini.
Sebagian besar lulusan program studi ini bekerja sebagai data analis di berbagai institusi dan lembaga pemerintahan ataupun swasta. Menjadi data verifikator di kementerian, perbankan, Polri, atau di berbagai institusi lainnya. Ada juga yang malah menjadi perwira karir TNI, dan bahkan ada yang diterima untuk bekerja sebagai research scientist di New York, Amerika. Kenyataan bahwa para alumni statistika ini relatif mudah mendapatkan pekerjaan sama sekali tidak mengejutkan, karena selain fasilitas dan sumber daya manusia yang mendidik mereka, para mahasiswa statistika juga termasuk yang sangat aktif berorganisasi dan berprestasi, baik prestasi akademik, penalaran, maupun di bidang seni dan olahraga. Lagi-lagi fakta ini juga tidak mengejutkan, karena persaingan untuk menjadi salah satu mahasiswa statistika USK tidaklah mudah. Karena program studi ini merupakan salah satu program studi yang sangat diminati oleh para calon mahasiswa. Sepertinya, para calon mahasiswa ini juga sudah sangat mengerti bahwa tiada hari tanpa data-data. Dan agar data-data ini berubah menjadi energi, solusi, atau rekomendasi, maka yang dibutuhkan adalah statistika.